Everything around us is made up of atoms. The word comes from a Greek word atomos, which means indivisible. The ancient Greeks theorized that there must be some smallest piece of matter that can't be split up anymore, so they came up with the idea of atoms being the tiniest possible particles. But we now actually know that atoms themselves are made up of even smaller particles. So let's dive in and learn all about the structure of an atom. So this here is called the nuclear model of the atom. It's a pretty good approximation of what is actually going on inside an atom. It's called the nuclear model because a really important part of it is the bit in the middle, the nucleus. The nucleus is made up of two types of particles, protons and neutrons. These both have a relative mass of 1. Protons have a positive charge, neutrons have no charge, they are neutral. Orbiting around the outside of the nucleus, we have electrons, and these will occupy energy levels or shells. Electrons have a negative charge and they have a really tiny relative mass. It's about 1/2000th of the mass of a proton or a neutron, and we sometimes call it negligible, which means so small it might as well be zero. Now, you might know from chemistry that different elements have different types of atoms. And in fact, it's the number of protons that defines an element. So, for example, any atom which has 6 protons is always going to be carbon. And any atom which doesn't have 6 protons can't possibly be carbon. It's the number of protons that makes the element that element. But the number of neutrons can be different. Some atoms of carbon might have 6 neutrons, some might have 7 neutrons, some might have 8 even. The number of neutrons doesn't define the element, and it can change within reason. The word that we use to describe atoms with a different number of neutrons is an isotope. So the example that I gave a minute ago, carbon with 6, 7 or 8 neutrons would be isotopes of carbon. Now, the way that we represent all of this is with the symbols that appear on the periodic table. So let's take carbon as our example again. It's going to look like this. The big letter represents the element. In this case, it's just capital C, it means carbon. The smaller number is called the atomic number, and that tells me how many protons this atom has. So in this case, it's 6. And the bigger number is called the mass number, and that tells us how many particles are in the nucleus. So it's the total number of protons plus the total number of neutrons. In this example, it's 12, which tells me that there must be 6 neutrons because I've got 6 protons and there are 12 particles in total in the nucleus. So 12 take away 6, meaning there must be 6 neutrons. So here's a few different isotopes of carbon. These are the ones that I was mentioning earlier, and you can see that the atomic number stays the same. It's always 6 for carbon, but the mass number changes, so we've got a different number of neutrons. These are 3 different isotopes of carbon. As a final note, any neutral atom will have the same number of electrons as protons. The charges balance out. But sometimes an atom might gain or lose electrons, and in that case we call it an ion. When an atom has become charged by gaining or losing electrons, it's called an ion. But this is a bit irrelevant to the topic of nuclear physics because, as the name suggests, we only really care about what happens in the nucleus in nuclear physics, and the electrons are not inside the nucleus. All right, well, if you kept up with all of that, then you can officially call yourself a nuclear physicist.